Optimization problems in mathematics. An optimization problem may involve finding maximum profit, minimum cost, or maybe minimum use of resources. Optimization problem is to find the optimum solution subject to constraints of the given problem. Optimization problems solved in mathematics. There are optimization techniques. What is linear programming?
This is exam 4, test 4 review, detailed solution, college algebra. In this exam 4 review, we'll look at the linear programming graphic method. This linear programming is a word problem about carpenter maximizing profit. The carpenter that makes bookcases and desks, that carpenter will make X bookcases and Y desks to maximize the profit. From each bookcase, he will make $40 profit. From each desk, he will make $75 profit. That means the objective function is profit equals 40x plus 75y, and this is to maximize this profit. Subject to constraint. For woodworking, he has only 600 hours available. That means he's going to use 600 hours or less. That is 5x plus 10y is less or equal to 600. And for finishing, he has only 240 hours available. That is, he's going to use 240 hours or less for finishing. That is 4x plus 3y is less or equal to 240. Then he has to produce 0 or more bookcases, and he has to produce 0 or more desks. And we'll use this constraint to graph the feasibility region. We'll graph these two constraints are these two lines, and he has to produce more than 0 or more than bookcases, which is x is 0 or more, that is above the x-axis, and he has to produce 0 or more desks, that is y is equal or greater than 0, that is to the right of y-axis. Then this is the feasibility region. He has less or equal than 600, that is below this graph line, and he has less or equal 240, and that is below this line. Then this is the feasibility region. Every point in the feasibility region is a profit. The maximum and minimum profit, they lie at the corner of the feasibility region. Therefore, we're going to evaluate the objective function, which is the profit, at the corners of the feasibility region to find the maximum and minimum profit. And it happened to be xy, which is x is bookcases, y is desk. He has to produce 24 bookcases and 48 desks to get a maximum profit of 4,560. That is, the carpenter shop will make a maximum profit of 4,560 when 24 bookcases and 48 desks are produced and sold. So this is exam 4 test 4 review, college algebra. This is additional review to your professor instructor exam test review, which should be your main essential review. This is STEM engineering college algebra. This exam for review tutorials is good for students in college algebra, business math, development math, intermediate algebra, high school algebra 1 and 2. To prepare for development math algebra support, watch my development math exam 4 test 4 review video. In addition to this, I'm sharing this with you only as additional help in addition to your professor instructor exam test review, which should be your main essential review. Number 25 is linear programming graphic method. Linear programming is a mathematical modeling technique in which linear functions is maximized or minimized when subjected to various constraints. This technique has been useful for guiding quantitative decisions in business planning, in industrial engineering, and in social and physical science. In business maths, we analyze both graphical method and simplex method. In this exam review, we will analyze graphic method. The application is maximizing profit. Dovetail Carpentry Shop makes bookcases and desks. Each bookcase requires 5 hours of woodworking and 4 hours of finishing. Each desk requires 10 hours of woodworking and 3 hours of finishing. Each month, the shop has 600 hours of labor available for woodworking and 240 hours for finishing. The profit on each bookcase is $40 and on each desk is $75. How many of each product should be made each month in order to maximize the profit? What is the maximum profit? So the first thing is we need to convert this, the word problem, we're going to convert it into a table. We have two products, bookcases and desks, and we don't know how many bookcases and how many desks we need to make to maximize the profit. So we're going to call them X bookcases and Y desks. Then the woodwork for the bookcases requires 5 hours and the finish requires 4 hours. And the profit is $40 each bookcase. And for the desk we require 10 hours for woodworking and 3 hours for finishing. And the profit is $75. And the constraints are we have only 600 hours for woodworking. That means we can use only 600 hours or less. Then for finishing we can use the maximum 240 hours or less. And the objective is to maximize the profit. So the objective function is maximizing the objective function. The profit is 40x plus 75y, and this is what we are trying to maximize. Of course, it is subject to the constraints, that is 5x plus 10y is the maximum you can use is 600 hours or less. Then 4x plus 3y, the maximum you can use is 240 hours, that is less or equal to 240 hours. Of course, you have to produce 0 or more bookcases, and you have to produce 0 or more desks. That means x is greater or equal to 0. So we're going to take this constraints, we're going to convert it into graphic and get the feasibility region. So first is x has to be equal or greater than 0, that means above the x-axis. Y has to be greater or equal to 0, that means to the right of y-axis. Then we have to take 5x plus 10y equals 600 and graph a line. Then 4x plus 3y equals 240 and graph the other line. So here when x is 0, y is 60. So when x is 0, y is 60. That is 1 point. Then when y is 0, x is 120. And that is the first line. Then we need to graph 4x plus 3y equals 240. When x is 0, y is 80. And that is this point. When y is 0, x is 60. And that is 60, 0. And that is the other line. Then you have 5x plus 10y is less or equal to 600, means below this line. And 4x plus 3y less or equal to 240 means below this line. That means the feasibility region is above x-axis, to the right of y-axis, below this line, and below this line. So this is the feasibility region. That means in the feasibility region, every point in the feasibility region is a profit. Then the maximum profit is at the corner of the feasibility region, and the minimum profit is also at the corner of the feasibility region. Then all we have to do is evaluate the objective function, which is profit equals 40x plus 75y at the corner points at 0, 0, at 0, 60, at 60, 0, and at 24, 48. But now how do you get this 24, 48? To get this 24, 48, we need to solve 5x plus 10y equals 600 and 4x plus 3y equals 240 simultaneously. Then find what is x, what is y. You can do substitution method, or you can just put it in the calculator. Create a matrix called F, and that matrix is for x is 5, 4, for y is 10, 3, then augmented with 600, 240, then do ref f, then that is 1001, and the result is 2448. That is, this corner is 2448. Then evaluate the objective function, which is the profit 40x plus 75 at the corner points. So first evaluated at 0, 0, that is 40, profit equals 40 times 0 plus 75 times 0, that is 0. Then evaluated at 60, 0, at this point, then profit equals 40 times 60 plus 75 times 0, which is 2400. Then evaluated at 24, 48, then profit is 40 times 24 plus 75 times 48, that is 4560. Then evaluated at 0.60, then the profit is 40 times 0 plus 75 times 60, which is 4500. So now here you have 0, 2400, 4560, and 4500, which is the maximum is 4560, and this is the absolute max. And this is when you produce 24 bookcases and 48 desks, then you will end up with the maximum profit. And the absolute minimum is 0 when you produce 0 bookcases and 0 discs, then you make nothing, it is 0. So that means you have xy, x is bookcases, y is discs, is 24, 48. So when you make 24 bookcases and 48 discs, then your maximum profit is going to be 4,560. That is, the Carpenter shop will make a maximum profit of 4,560 when 24 bookcases and 48 discs are produced and sold. And this is when you have 2 by 2 variable, you can do graphic method. But when it is 3 by 3 or 4 by 4 or 100 by 100 for that matter, or 1000 by 1000 like they do in Amazon, then doing solving graphic method becomes almost impossible. Then you have to use the other method, which is called Simplex method. And the Simplex method, you can use a calculator, but the best way to solve the Simplex method is using Excel sheet. And that is what big businesses like Amazon, they use Excel sheet or some kind of programming to solve a multi-variable, could be 100 variable, 1000 variables, and that's what they use. And thank you. Please subscribe, share, and like. And ask your friends to subscribe, share, and like.
Wow.